Okay, so a modulus, do we know what modulus means? Another word for? No, not imaginary axis. So when we've got a modulus, hello. So modulus, another phrase for that, you could see it as the absolute value. And to sum it up, basically, it's like if I was 3 meters to the left, 4 meters to the left of the door, I'm not going to say I'm minus 4 meters. I'm just 4 meters, right? So we want the absolute value of stuff. So basically, if I have minus 4 and I pop that into the calculator, it becomes 4. When we're talking about a graph, let's imagine our y equals x, our beautiful y equals x graph. And why should we love this y equals x line? Where have we seen that before? Yes, what do we do? Inverse functions, okay? So a function, if it is one-to-one, it has an inverse, and graphically that means that you are reflecting it in the y equals x axis. That's all, you know, everything is linked. We've done some of this stuff, okay? So we look at our y equals x graph. We know that y equals x looks like this. Yeah? So if we have 1, when x is 1, what is the modulus of 1? Well, it's 1. That's no big drama. So I'll do this now. No. Y. I know what I'm doing in my head. So y equals the modulus of x. So back to the good old tables of values thing. So if I had 1, the modulus of 1 is just 1. If I had 2, the modulus of 2 is just 2, and so on and so on. But if I have minus 1, the modulus of minus 1 is 1. So down here, where I've got minus 1, instead of being minus 1 for this function, it will be 1. If it was minus 2, it would be positive 2. So we end up with the modulus function looking like this. Okay? It does not exist downstairs in your minus plane. It works the same way as some of our other functions. So if I had y equals the modulus of x and take 2, what do you think would happen? It just drops down by 2. That's right. Drop down and Here's a curly question for you. What do we think will happen if we had y equals inside the modulus x take 2? Yeah, it's going to be a horizontal translation. Don't worry, you don't have to do madly copying or anything unless you want to. So it'll be here, bloop, bloop, because when x is 2, 2 take 2, you get that 0. So the big deal is, do you know how to put it into your calculator? Yes? No? So grab those calculators. When you're in a normal calculator option, numeric, F4, and you get your absolute value. So you can put that in, and I'm not telling you a lie, because if we go minus 4, it gives you positive 4. Huzzah! Not going to use it too much over here. The main part is when we are graphing. So into our graphing mode. Hell's bells, why does that stay there? And let's have a look at modulus of x. Okay? Faster in the one mode. Yeah, I was going to say. Oops, why did I do that? There are many options. So if you hit your math mode, that gives you really good zoom zoom and well done. Yes, it's there too. So maths mode. Make sure you go in and look at all these. They're really good. There's hidden things in there that you can mess around with. Anyway, back to graphing. Menu 5. So option numeric. Absolute value. Let's have a look at x. Okay, I'm just going to check my scale, shift view window, go back to standard, and huzzah. Are we good with that? So that is your basic modulus. Obviously, we can apply that to quadratic graphs as well as linear. So what do you think if I took the modulus of a quadratic? What would that look like? Let's do our normal. Don't do it on your graph yet. Let's have our y equals x squared. What would... So we've got y equals x squared. What would you expect the modulus of x squared to look like? Exactly the same. That is correct, because all you're doing is you're turning any negative values into a positive. And so it basically goes straight over the top. What about y equals x squared take 4? What does that look like? Right, we just drop that downstairs to 4. So now, oh yeah, the colour combo is working for me. What do we think that would look like? No. To move it to the right, that would have to be x take 4 squared, right? Different. Remember what we just said, the modulus is making anything negative become positive. So this bit here, that's negative, it will now become positive. So that doesn't change, that doesn't change, but this bit here, you get a groovy little, I know, look at it. So let's play with that one. Let's have a look, see if I haven't told you some furfies. So again, option, numeric, absolute value, x squared take 4. Make it the sense. And we are going to go and have a look at different sorts of graphs in your outline. If we have a look, they're going to say, okay, what happens if we graph the f of the modulus of x? What if we graph the modulus of f of x that we've just been doing? And what if we're graphing the modulus of f of the modulus of x? So we're just going to mess around with some of those things. We've got our calculator. Sometimes I can put variables in there, so your calculator is no good. And we just mess around with that sort of stuff. But that's where we're heading today. How does that grab you? Awesome. So I don't think we need to do question 1. Would we agree? It's all just substituting in, same as 2. Question 3, they're just trying to make sure that you get the gist of when we square a positive and when we square a negative we get a positive answer, and so that just leaves us, if you still get a positive. So nothing to see here. I wouldn't even bother. Properties to discover here. So that's a property that I think we already know. Yes, we already know. Copy and complete. So what could you tell me? Do you want to do that one or not really? Again, you'll come up, it's a bit of a surprise, but come over here. Yes. Do we think that this is true? So this is true. Modulus of, true or false for all values. I think you should do that one just very quickly because it's not going to be true or false all the time. Want to do it quickly? I could do it. Rows of those to tell me what? If I've got 3 plus 7, I get 10. Well, that's beautiful. If I have the modulus 3 plus the modulus of 7, yep, I get 10. So can we say, yes, it's always true? No, because what if I have 3 plus negative 7? That gives me negative 4, which becomes positive 4. And of course, if I had the modulus of 3 plus the modulus of negative 7, that then still is 3 plus 7, and that is 10. So no good. the modulus stuff doesn't work like our algebra stuff used to work. So I know it's a bit mind-numbing, but it was worth actually having a look at that. Okay, use the fact that x equals square root of x squared to prove the following. So we're actually going to square it and then square root. So if we take the left-hand side, so we okay with C? We take the left-hand side, we're going to go a minus b, and we're going to follow this. So what does it say that's going to equal? It means that this would be the same as a minus b squared, all square rooted. Okay? And then you just plot along. And we go, okay, well, I know that a minus b squared, that would just be a squared minus 2ab plus b squared. Now we take the right-hand side, and I think we can already predict and see what is going to happen. So b take a all squared will be b squared minus 2ab plus a squared. Huzzah, same thing. They equal each other. So we're good with that? Can I keep going? Awesome. So you have a look. We're skipping number 5 because I think, again, that's just a little bit insulting. Again, could you imagine what's going to happen, true or false? Tell me, give me an example why it would be false. No, go for it. Why would it be false? So if one's positive and one's negative, right, whatever happens, that will be a positive answer. And the same thing with this, that would end up being a positive answer as well. No, that's good. You can have a go, you do, and so on and so forth. So, okay, the adding and the subtracting, negatory, positive's okay. So, this is the main bit that we are wanting to play around with. Okay, breaking the modulus up into their little segments that we can have. So I think I did it better in my OneNote, but yeah, I think so. So we're basically breaking this up and saying it can look at 2 different graphs. So again, this is all on your OneNote. You can go on in peace, take the notes down if you want to in a moment, or you can take it down now, your call. When x is greater than or equal to 0, it's our normal y equals x because it doesn't change it at all. But when we're talking about it is less than 0, right, that's going to be equivalent to the minus x. So that's how we get our y equals minus x graph up there. It changes a little bit, as we said with our translation of when we have x take 5. When does this modulus sort of become redundant or not used? If x was greater than or equal to 5. Because in 6, 7, 8, you're going to get the same answer whether the modulus is there or not. Agreed? But when it is less than 5, that's when we say it's going to be the minus of what is in our modulus. Is that making sense, or am I talking gobbledygook? And so we're actually graphing the minus of that. So minus x minus minus 5, minus x plus 5, and that's what we have here. But again, we're restricted with our domain that it only exists for when x is less than 5. It doesn't keep going because otherwise it would go down there and then it's not negative. So you could be asked to sketch these graphs and show the 2 separate functions that it could be. Think you've got that? Because then, and I don't want you to see the whole thing, maybe I don't look. So we just looked at when we had y equals the modulus of x take 5, and we went, yeah. We split it up into the 2 functions when x is greater than 5, so that would just be x minus 5, and then we had when x is less than 5, so you pop the minus in front, so that's going to be minus x plus 5. Were you happy with that? And you go, this is nice, 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 and it's still nice, but we can take it up just one little notch, and now we've got 2 modulus in there. Rutroll, Charlie Brown. So again, you have to go and have a think about what's going to happen here. Now clearly, with this, we have something different is going to happen when x is, well, when x is greater than or equal to 6, would you agree the modulus has no effect on this whole function? Yeah? So that would just be y equals x take 6 plus 2x, and we would end up with y equals 3x take 6. We're tempted to go, yeah, okay, well then the other one would be x is less than, or, is less than 6. And we have y would be minus x plus 6 minus 2x. So again, all you're doing is when it's a minus, you're taking that into account. So that would be minus 3x plus 6. And you think, all done? Niet. What if there's some values in between these? Because this one here goes for greater than 0 and less than 0. I'm trying to think of a number that I haven't covered. Right, so what if we're talking about x equals 2? When x is 2, this is going to have an effect on the modulus, isn't it? But this one will not have an effect on the modulus. So we've got this other function that's in between where for what values will this one be affected, but this one will not, and vice versa. So when would that be? Right, so when it's greater than, we're all good. Okay. Oh. When it was less than 6, right, we think here, but that one is not going to be, I stuffed that one up, that one will already be affected, yes. So when we're talking about what happens if we're minus 2, that one still gets taken care of, okay? So when we're between 0 and 6, the first one will be the minus, but this 2x is unaffected. So you've got to suss when is one affected, when is it not. So I like to, didn't do that on that one, but I like to sort of say, what are my boundaries here? And then I can find out the one that's in between. We end up getting our functions, and so we then see that it is a 3-pronged attack for this graph. Check it out. Put that into your graphics calculator and see if you get. So I'd hate to listen back to what I just said before because I don't think I made that overly clear. But anyway, if we have a look at our next one, okay, when is this going to be always positive? Do we agree when it is greater than or equal to minus 2? When is this going to be always positive? So 2x take 4. When is it greater than 0? Solve when it's greater than or equal to 2. So then I sort of just break it up and I go, okay, when have we got our effects and what's going on here? So when it's greater than or equal to 2, that's always going to be positive. That's always going to be positive. Agreed? So then I'm going, geez, why have I got negatives in there? But I had it because it's there. Okay, so you're just removing the modulus and then away you go. And that's how you get your first function hither. What's happening in between 2 and minus 2? Well, is this one affected? So pick a value, so like 0. 0 plus 2, is the modulus having an effect on that? No, still just going to be positive. So I keep it as the minus. Whereas here, 2 times 0 is 0, minus 4, the modulus is going to affect that. So that's when I counteract with that minus. Minus and a minus make a plus, tidy up, I get my function. When it's less than 2, well, they're both affected, so it's minus minus to all of them, plus plus, and we get our third function. How's that go? The ones that they give you in your textbook aren't as tricky, but you could be asked to state the functions for each. Again, you can always use your calculator to work backwards, but try and get the swing of. So I might put a couple more of these in our revision. Is that handy? So if you just take a couple of minutes to finish your, have a go at these ones, please.